You're welcome, my dear learners and viewers. Good afternoon. This is Cherubert, Life Academy Nursery and Primary School. I'm once again here to present a lesson in Primary 6 Mathematics. So for this session, I'm just going to talk about the things that we discussed in the previous session. In the previous session, I talked about prime factorization. So after understanding what we mean by prime factorization, we said in prime factorization, we divide a given number using the possible prime factors for the possible prime numbers. So we said when I divide a certain given number completely using the possible prime numbers, it means I've completely prime factorized that number. That was prime factorization. So we're going to use the same idea in the lesson of today. So today I'm looking at finding the G.C.F and L.C.M from the Venn diagrams after prime factorization. So after prime factorization at a P.6 level, we can go ahead to show the prime factors on the Venn diagram. Then from those very prime factors on the Venn diagram, we can use them to find the greatest common factor or the G.C.F, or we can also use those prime factors on the Venn diagram after prime factorization to find the L.C.M. That is what I'm going to talk about in this session. So probably let us start from some example here. Examples which shall first of all show the prime factors on a Venn diagram. This work was taught in primary 5. We're just going over it. We can first have this question here. Show the prime factors. Show the prime factors. Show the prime factors of, for example, 30 and 36 on a Venn diagram. On a Venn diagram. This is the question. The question says, show the prime factors of 30 and 36 on a Venn diagram. So before we go to the Venn diagram, we need first of all to prime factorize these two numbers. Then we get the prime factors. After getting the prime factors of 30 and 36, we shall be in position to show them on a Venn diagram. What I'm going to do to prime factorize 30, we shall draw up a ladder, just a column. I'm using the ladder method. A column. You look at this, put a provision for the numbers. Remember, we are using the possible prime numbers. I think you remember the prime numbers where we talked about 2, 3, 5, 7, 11, 13, and very many others. So the number I'm starting with is 30. So 30, it is an even number. Out of the prime numbers, it can first be divided by 2. Then when I divide 30 by 2, the answer gotten is 15, right? This one has brought me to the second step. So on the second step, from the list of these prime numbers, the prime numbers from the list we gave, we can actually give it again under the prime numbers. We are having 2, 3, 5, 7, 11, 13, 17, and very many others. That is a list of some of the prime numbers. So from there, after dividing 30 by 2, I've gotten 15. So 2 cannot still divide 15 completely. I'm going to go and I choose another prime number which can divide 15 without a remainder. And in this case, I'm going to use a 3. Then I will say 15 divided by 3, each one gets a 5, right? Then from there, the next step has the answer as a 5. Then I also ask myself, which prime number can divide 5 without a remainder? So automatically, I'm going to use a 5, right? So I will say 5 divided by 5, the last answer becomes 1. And when you get 1 as the last answer, it means the number we are prime factorizing is completely prime factorized. Therefore, I will simply come and I say 30 is equivalent to, I'm going to write these ones, the numbers I've used to prime factorize or the prime factors using the subscript form. So 2 is appearing for the first time, so we shall have it as 2 for the first time, comma. Then 3 is appearing for the first time, I will say 3 for the first time. Then 5 is appearing for the first time, I'm going to say 5 to subscript 1, right? So I've gotten the prime factors of 30. I can also go ahead and I get the prime factors of 36. What should I do? I will draw up a column or a ladder like this, then provide where to write the numbers. 36 is written. Then I ask myself, out of the prime numbers, which one can divide 36? Automatically, I'm going to use a 2. So when I divide 36 by 2, the answer gotten is 18, right? On the second step, I'm having 18. I ask myself, can this 2 as the first prime number used, can it still divide 18? The answer is yes. When I divide 18 by 2, the answer gotten is 9. It has given me the third step. On the third step, I'm having 9. But 9 cannot be divided by 2 without a remainder. Therefore, I'm going to go and pick another prime number, which in this case shall be 3. Because 3 can divide, 9 can be divided by 3 without a remainder. When I divide 9 by 3, I get 3. Okay? Then on the fourth step, I'm having the last answer as 3. Yet I'm supposed to divide it until it is exactly 1. So I'm just going to say I divide it by 3, such that I can say 3 divided by 3, the answer is 1. Since I've reached 1, 36 is completely prime factorized. Therefore, I'm going to say 36, its prime factors are equivalent to 2 for the first time, comma, 2 for the second time, comma, then 3 for the first time, and again 3 for the second time. Therefore, I've gotten the prime factors of both 30 and 36. But the question told me to show the prime factors on the Venn diagram. Therefore, I'm supposed to go and draw up my Venn diagram. This is what I'm going to do, like this. I'm having this, like this. Then I will say, the first one is for the factors or prime factors of 30. The next one is for the prime factors, I've said factors, prime factors of 36. Okay? So after drawing the Venn diagram, I am supposed to go and check out the common prime factors. In the prime factors of 30, I've gotten 2 for the first time, 3 for the first time, and 5 for the first time. Under the prime factors of 36, I've gotten 2 to subscript 1, 2 to subscript 2, 3 to subscript 1, and 3 to subscript 2. So which one of these ones have common subscripts? I can mark them. 2 for the first time appears in the first set, it also appears. Therefore, it is a common one. I'm having the 3 for the first time appearing in the first set. I'm also having it in the second set. Therefore, these are the only common members. So I will represent them under the intersection part of the Venn diagram. So this is 2 for the first time, or 2 to subscript 1. Then 3 to subscript 1. So what remains under the prime factors of 30? It is only 5 to subscript 1. Then what remains in the set for the subscripts of 36 are 2 for the second time and 3 for the second time. By doing that one, I will have represented the prime factors of 30 and 36 on a Venn diagram. Okay? But I want to use this very question to go ahead and give some other sub-questions of it. Probably from this first part of the question, they can say, part A, find the G.C.F. The G.C.F, we have already looked at it, of 30 and 36. So from this first sub-question of the major question, we are talking about the G.C.F, or the greatest common factor, which we can also call the highest common factor. So in this kind of a question where we are using the Venn diagram, when I want to get the G.C.F of these two numbers, I simply multiply the prime factors in the intersection region. Therefore, I will simply come and say G.C.F shall be equivalent to, I will say 2 for the first time, multiplied by 3 to subscript 1. So on the second step, I remove the subscripts and I say 2 multiplied by 3. The answer gotten becomes 6. Therefore, the G.C.F of these two numbers using this question is 6. Right. We are looking at the G.C.F and L.C.M using the Venn diagram from prime factorization. The second sub-question, let me call it question part B. They say work out the LCM of 30 and 36. That is the second part, the second sub-question of the major question. Using this Venn diagram, this part of the question says work out the LCM, or the lowest common multiple. They are saying using the Venn diagram. Excuse me. So when we want to get the LCM using this very question of the prime factors on the Venn diagram, I must get the product of all the prime factors. I multiply all the prime factors in both sets. So I will simply come and say the LCM shall be gotten from the first step. We can write with the subscripts. 5 for the first time multiplied by 2 to subscript 1 multiplied by 3 to subscript 1 multiplied by 2 to subscript 2 multiplied by 3 to subscript 2. Then on the second phase, you can remove the subscripts and say this is 5 multiplied by 2 multiplied by 3 multiplied by 2 multiplied by 3. You can pair these numbers for easy multiplication. We can say 5 multiplied by 2 is 10 multiplied by 3 multiplied by 2 is 6. Then that 6 multiplied by 3, we are getting that one as 18. So when I multiply it completely, the last one gives me the answer as, when you multiply 10 by 108, when I multiply 10 by 18, the answer I get is 180. Therefore, the LCM of those two numbers, using the Venn diagrams after prime factorization, shall be 180. That will be the way to go about that question. So, dear learners and viewers, because of time, I would have continued with more of the questions, but I want to end the lesson. Thank you so much for being part of this lesson. But at the end of it all, there are some few questions that you're going to answer. Thank you so much. Our dear learners, these are some of the questions you're going to answer after the lesson we've just gone through a few minutes ago. Thank you so much. I think you'll be in position to enjoy the questions. Stay home, stay safe. Teacher Robert.